Greetings. Okay, so today's topic is going to be basically an extension of the previous video that I talked about a little bit more in depth when we were talking about the three sort of skills that you needed to have in order to get work in the industry. So the third one that I sort of talked about was about understanding about game engines, essentially, and to this extent, there's a little bit of a situation to understand what it's like to design audio for a game. And in order to do that, you kind of have to think like a game designer. So there is a nice quote from none other than Richard Stevens, whose book called The Game Audio Tutorial. He wrote in an email at some point on a news group and said, "Game audio forces you to think like a game designer." And I thought that was a really excellent idea. And I want to sort of extrapolate and continue sort of discussing what that actually means. And so obviously, one of the biggest things is that you have to understand the game's structure. As we said in the previous video, the whole idea of games is that they can be a million different things. There's like stars in the universe. There's millions of them. So therefore, there's going to have lots of different structures that are going to be there. And that structure of the game is going to be really kind of important in order to figure out what you can do, what you're allowed to do in many respects, even with middleware, inside the game as far as what your options are, right? So the thing is that, you would need to understand if there's like game levels, how you would then design for those levels, if there's sections of each of those levels, there's branching plots of some kind or another, or there's some kind of character development. All that stuff's going to be very, very important in order to be able to sort of, do what you want to do, essentially. So when you're thinking like this, you're thinking like a game designer, for example. If we talk about like, restrictions that you have, for example, and in the sense that, you're doing this design, for these kinds of things, you're going to be subjected to all kinds of limitations, not the least of them being the platform that you're going to be, doing it on. So, potentially you might say you're doing it on as a mobile platform game, then you're going to have certain kinds of limitations. And one of the typical limitations we're going to talk about, we'll probably extrapolate, we'll describe more of this later, but something called audio budget. Audio budget is certainly not how much you're getting paid for the work, but how much you're allowed space for the work. And it might be RAM as well. You might have a certain amount of RAM budget that you're allowed. You can't use up more than that RAM budget, right? So there's these limitations already that you're having. You might have an additional budget on top of that, which would be a processor budget. In other words, you can't go over a certain percentage of usage on the processor or on a processor if you're doing, let's say, console games, or you have multi-core kinds of things going on, and of course there's also a money budget as well, and there might also be artistic limitations in terms of, what they're planning on doing, essentially. So the deal is that when you think like a game designer, well, a game designer is basically a programmer. And I tend to think that programmers think in terms of what is called game logic. Now, game logic is basically, the various things that are happening inside the game, how the various events can flow together in terms of whether there's physical interaction or whether there's interaction with parameters in the game of some kind or another, or stuff like that, basically. Now, game audio implementers and game audio people are usually not programmers, but, in the case of dealing with things like middleware and stuff like that, or if they're advanced scripting or whatever, they will create their own logic in order to be able to do cool things with the sound. And that's what I call sound logic. So you have game logic and you have sound logic. So you have the game logic is, stuff that happens in the game. Sound logic is what you can do once you're allowed to sort of play the event inside the game, essentially. So it's useful to know the division between them and kind of where things kind of come up, essentially. So I guess the first thing to talk about specifically is all of this is all going to be related to the code in the game. And game code is fast. Game code runs really fast. It runs, at the very least, it usually runs every frame, or it could even run even faster than that in terms of cycle. So things are always constantly happening inside game code. So that's going to be a little bit of a challenge for game audio folks. You can't trigger audio events unless you want granular synthesis, right? So if you trigger sound like every single frame, it's going to sound like It's not going to be very useful, basically. You can change sound parameters or effects, but if you do that kind of stuff inside of games, that could be CPU expensive. In other words, it's going to cost too much processing power in order to make, to work correctly. So you need to basically, in comparison to the game code, game audio events are generally slower. And game music as well. We throw in game music when we say game audio. It means both sound and music, of course. The idea is that you have to find various methods to kind of slow or filter the data in the game code, or use various things that aren't really like strongly, carefully sort of timed, or have like very, very fast, changes. So you have to figure out a way of being able to like pick a certain amount of time that you can maybe wait before things happen, and stuff like that. And all of these things, there's lots of different methods to be able to do this. We have the Boolean triggers. We have Boolean switches. Now, Boolean basically just means true or false. We'll talk a little bit more about this. You have basically kinds of fast parameter switches. You can have continuous parameter changes. You can have things like timers or any combinations of these. So let's go into talking a little bit about how those various things work. We're going to use one of the most basic kind of things to talk about, which is a trigger. Okay, so a trigger is basically just sort of like a volume or an area. Think of it like a big square, but it's like an invisible square, really. And the idea is that if you walk into the square, you can make a sound happen, or you can play a piece of music or whatever, right? So the idea is that a trigger is one of probably the easiest things to use. It uses something, a physics component that is fairly common in games called a collider. And the idea is that if an object overlaps another object in that collider, then it'll just say, hey, there's this object inside the trigger. And all it really does is it just looks for that point at the point of the entry. And then therefore it'll just trigger at that point of entry. So it's one of the easiest things to use. It's one of the easiest on the processor. And it's just a simple physics-based logic. In case of game engines, they usually want to know whether you're entering that area or you're exiting that area, or maybe if you're staying in that area for more than one frame or a certain time period, that kind of thing. And the idea is that you can basically use that in order to be able to trigger a sound there. But you can also use, but the problem, of course, is, let's say if you have something that's like a trigger right there, and let's say you walk into it more than one time. Well, if you walk into it more than once, then it's just going to keep playing. What if you had a piece of music you wanted to play? Well, if you walk into it again, it'll just start playing again. So you don't want that to happen, right? You want that to basically say, only one time. When I walk into that trigger, I'm going to happen one time. So you could treat it maybe like a pickup in a game. You know how when you walk over pickups in your like some kind of game, and that object will disappear, right? So you could have a situation where when you walk into that object, it triggers, and then it also disappears. But you can also keep that object there and use what's called a Boolean, or a true or false sort of statement. And it's really good for making something happen only one time, or for filtering repeated values or anything like that. And it can be reset if you want to allow a re-triggering if you feel like doing that. So what happens is that a typical Boolean switch kind of sort of thing is that normally when you walk into a trigger, you might have like an if-then statement. So in other words, like, if this happens, then do this, right? Now, normally if it happens is that if you had the trigger there and you didn't have the true or false, the Boolean option, you would have, every time you walk in the trigger, it would say, oh, well, you entered, so I'm going to play the thing, right? So what if you only wanted to make it once? Well, then you put in another check inside of the previous check. So you make that check say, you just create some kind of variable, right? You create some kind of thing that says, have you played one time, right? So, and that's going to be either true or false. And so what happens is you have that option automatically set to say false. And then you can say, okay, is the trigger entered? Yes, it has been entered. Then is the one time playing false, right? And it is false to begin with. But then what happens is we'll play that sound, or we'll play that piece of music, and then we will flip that variable to true from false. And that makes it, then the next time the trigger is entered, it's going to enter the trigger and say, yep, trigger got entered. But then is played one false? No, it's true. What's going to happen? Nothing. And that's how you get a one-time trigger. So that happens all the time. So you can basically make that kind of stuff happen. Now, Switches will also work for parameters. So you can actually have a parameter inside the game that would be like a numbered parameter or something like that, or even a named parameter. And you can say, is a parameter a particular value? And if you walk into it, it'll play one sound effect. And if the parameter changes to another thing, you walk into it again, then maybe it'll play a different sound effect. And if it's maybe more than a certain amount, then maybe you could just blow up everything. So this is really good for any kind of immediate parameter switching, like things like footstep surfaces. It's really kind of common, even though we might be using names instead of numbers or something like that. But you can arm or use specific weapon types like this. So like you're going to switch your weapon or something like that. You could say, hey, well, for 1, well, we're going to be on the pistol. And if we're 2, we're going to be on the rifle. And if we're 3, we're going to have the grenade, or something like that. So you can use this basically with triggers for more of this versatility. Another thing to mention is all of the sort of physics components that are really common to games. And what we were mentioning about the triggers was based on something called a collider. So the deal is a collider is basically the thing that prevents your character from falling through the floor or from you going through walls or anything. It creates a sort of sense of solidity effectively, right? There's also another component here called a rigid body. And a rigid body basically is the object that basically has sort of motion and inertia and has sort of like all the physics kinds of characteristics of like gravity and things like that. So rigid bodies are going to be good for that kind of stuff. So if you put a rigid body on an object, then it will fall on gravity, and that might hit an object that has a collider, and therefore it will actually hit a surface. If it didn't have a collider to hit, then it will just pass right through that object. And so rigid bodies and colliders are really going to be very commonly done, right? And that's the idea. So then a third option here is called raycasting. Raycasting is basically like when you fire, it's like a geometry ray, right? You start at a single point and you go outward basically infinitely. So in the case of like a AAA sort of game, like a shooter game or whatever like that, and you're shooting somebody, what's actually happening is that you can potentially send out raycasting to that object. And then if it hits that object, then you've damaged your enemy or something like that. So there's all raycasting gets done constantly in games. Now the thing about it is that physics events inside game engines often fire very frequently. Okay, so in other words, if you want to have a situation where 2 objects bang themselves together, right? You can have 2 colliders with rigid bodies, and they basically are just like, say, 2 physics objects, and they just collide together, So what happens is that you might get from the system a whole bunch of data saying bang, 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 bang. Like I hit. And what you want to do is make sure that only one of those gets registered. Otherwise, what's going to happen is it's going to try to trigger your event a whole bunch of times. It's the same thing with rigid bodies and stuff like that. If they're moving too much, you want to filter the data so that you're not getting a ton of information. So this is just one of those kinds of things that it's useful to know how to do a little bit. Now, again, we're not going into the specifics about how this specifically happens, but these are just things to kind of keep in mind, that what'll happen will be like if you're dealing with a game and all of a sudden your event gets firing a whole bunch of times, you can pretty much bet that what's happening is that the physics is a little too, not quite tuned enough to be able to, say, register properly when a certain amount of activity has happened, to only register that activity once and not a whole bunch of times. You also might have a situation where it's not sensitive enough and it doesn't fire at all. So there's different possibilities in this regard, but it's more often that if it is firing, it's likely to be firing a little too often. Okay, so that's all for this one, and we're going to basically keep on doing this and keep on talking about this subject because I think it's a pretty important one. And so if you're interested, subscribe, and we'll be able to find out more about what's going on. And if you really want to know when this video next part's going to drop, please click the notification bell. And if you want, leave some comments about your thoughts on this kind of stuff, and I'll be happy to answer what I can. So we'll see you in the next one. Take care.